Hi everyone. So today we're going to be working on a couple of different things. There are several things that we're going to be working on. Things like adding and subtracting, multiplying like binomial radicals, expressions. How do we rationalize the denominator if there's two terms in the bottom of the fraction, not just one? What do we do if the radicals are not the same indices? Apparently I've been saying that wrong. So there's a bunch of different objectives today that we're going to try and accomplish. All right, so we're going to be able to add and subtract radicals. We're going to multiply radicals that are two or more terms, rationalize denominators with two terms, and simplify products and quotients that have different indices, meaning different index like square roots, and try and divide that by a cube root. And what do we do about that? All right, so let's talk about adding and subtracting first. The first thing we have to worry about is, are they alike? So think of this as similar to adding and subtracting like terms with variables. You can only add a 4x with another x. You can't add an x with an x squared. They are different terms. So that's kind of like what we have here. There are two conditions that have to be met. They have to have the same index. So in other words, square roots with square roots, cube roots with cube roots, four roots with four roots. And what's underneath has to be exactly the same. So the square root of 2 and the square root of 2 can be added, but the square root of 2 with the square root of 7 cannot. So it's very specific about what you can and cannot add. Okay, so let's take a look at this. Let's combine some like terms and see what we can do here. Okay, so the first thing we want to know is, are they the same root? So they're both square roots. And are they the same underneath? Well, they're both 7s. So yes, we can add these together. Now, how are we going to add them? Well, we're going to add the coefficients. So think of it just like a number, or when we add variables. So if it's 2x plus 4x is 6x. Well, 6 square roots of 7 plus 4 square roots of 7 is 10 square roots of 7. That's it. But we have to make sure that the roots are exactly the same, because if they're not, we can't add them. All right, let's try this one. So these are all fifth roots. Oh, no, that's a cube root. So we can't add them. Even though he's 4x underneath the radical, have to be both the index and the radicand, the guy underneath, have to be the same. So we're very, very specific about that. So we're just going to add the 6 and the 3, and we're going to get 9 fifth root of 4x minus the cube root of 4x. And that's as far as we're going to be able to go. Let's try some more. All right, so here they're not exactly the same, but 8 can be simplified. So that's the next thing we have to worry about. Can we simplify the number underneath the radical? So we know we want to break 8 down to a perfect and something that's not, and 4 is our perfect. So this is the square root of 4 square root of 2, or 2 square roots of 2. All right, so we have 3, 2 square roots of 2, minus 5 square roots of 2. Or 6 square roots of 2 minus 5 square roots of 2, because I'm going to multiply the 3 and the 2, and we're going to get 1 square roots of 2, or you can just write it as the square root of 2. All right, let's try this one. I have 2 square roots. I have a square root and a square root, but one's a 5 and one's a 3. Can't do anything. This is already simplified. We can't do anything with it. So I'm just going to write simplified. I mean, we're not going to write no solution, because that is the solution. So we're just going to leave it like that. All right, let's try this one. Again, all of our radicals are square roots, but I have a 2, I have an 8, and I have an 18. Well, we already did 8. We know 8 is 2 square roots of 2. Okay, so we're going to do some. Now we've created a square root of 2. Let's take 18. Well, we know 18 is 9 and 2. And 9 is our perfect square. So square root of 9, square root of 2, or 3 square roots of 2. Again, notice I did some work on the side. So we're going to like take our information, put it on the side, and kind of work through our simplification and then come back and put it in the problem. So we have plus 3 square roots of 2. All right, these two can be multiplied together. So we get 5 square roots of 2 plus 6 square roots of 2 plus 3 square roots of 2. And now that it's all simplified, we double check and make sure that all of our radicals are exactly the same, square roots and the number underneath, which they are. So 5 plus 6 is 11, plus 3 is 14. So 14 square roots of 2. All right, let's come over here. Oh, they're all cube roots, and they are all cube roots of 2. But I can't add with the 7x because, again, you can only add variables that are exactly the same. And 5 in the first one, the 1, doesn't have it. So I'm going to be able to add this and this, the square cube root of 2 and the 5 cube roots of 2, to get 6 cube roots of 2. And then the minus 7x cube roots of 2. I can't add him, so there he is. Okay. Now, we can, just so that you might see this as an answer, put it like this. I'm not a fan of that. That really doesn't do much for me. So I'm good with 6 cube roots of 2 minus 7x cube roots of 2. All right, let's try one more. Okay. Whoa, that looks a lot, but it's not really. They're both cube roots, so we may be able to add them if the first one reduces down to 2y. So again, we're going to use our shortcut. 3 goes into 6 twice. Okay, with no leftovers. 3 goes into 4 once with 1 left over. And the 2's still underneath, so there we go. Oh. I don't think we're going to be able to add anything, but we did simplify to make it easy to simplify the expression. And again, we could, if we wanted to, write it in parentheses like we did over here. So you can do that. If you choose to do so. Okay, so with adding and subtracting, we're going to want to simplify our radicals if we need to, and then only add and subtract radicals that have the same root and the same numbers, or same radicand. It could be numbers or variables underneath the radical. All right, so when we do products, okay, so let's move on to multiplication. We've already done all the process. We're going to do distributive property here. Okay, you're going to do FOIL, or your split method, your box method, whatever works best for you to multiply. We're multiplying. And the thing is, with multiplying, I just want to say the right thing here. You can only multiply square roots with square roots, cube roots with cube roots until we fix it. So that's what we're going to keep kind of like the same root. The numbers underneath don't have to be the same when you multiply. Okay, so let's try it. I'm going to do the square root of 3 with x. So this is a distributive property one. So x square root of 3, because you cannot add an integer or a variable without being underneath the radical. Okay, so you can't do anything with that. But we can do the square root of 3 with the square root of 5. They're both square roots, and 3 and 5 are both underneath the radical. So we get minus square root of 15. And that's it. Okay, so here they're all cube roots. So cube root of y times the cube root of y squared is the cube root of y to the third plus cube root of 2y. Now, whenever possible, we're going to want to simplify. So if you notice, the cube root of y cubed is just y, cube root of 2y. Here we go. All right, let's try this one. Squared. Remember, that just means 4 minus the square root of 7 written twice. So this is your FOIL, split to distribute box, whatever you use to multiply two binomials. So I'm going to just do FOIL, so 4 times 4, yeah. And remember that 4 and the 7 can't go together, so we're going to get 16 minus 4 square roots of 7 And then here we're going to have 4 square roots of 7 minus 4 square roots of 7 minus the square root, or plus the square root of 49. Okay, so we can put some things together here. Oh, we can do this. This guy is 7. So 16 minus 8 square roots of 7 plus 7. So we can do 16 and 7. And we're going to get 23 minus 8 square roots of 7. Okay, that looked a lot harder than it actually was. Let's try another one of those. Again, looks a little overwhelming, but remember, you're just going to do your FOIL. Remember, numbers, integers, and numbers with numbers, radicals with radicals. Okay? So 4 square roots of 9, because we're going to do the square root of 3, square root of 3. Okay, again, we're doing this. And then we're going to do this. Okay? All right, so 4 square roots of 3 times the square root of 3, 4 square roots of 9, minus 20 square roots of 6, plus square root of 6 minus 5 square roots of 4. Now we're going to try and simplify anything we can simplify. Well, the square root of 9 is 3, minus, and then we got 20 plus negative 20, 19 square roots of 6, and minus 5 times 2. So this is 12 minus 19 square roots of 6, minus 10, or 2 minus 19 square roots of 6. Okay, let's do one more. No numbers. All right, again, square root of A, square root of B, square root of B. There we go. Okay, remember, numbers with numbers, radicals with radicals. So the square root of A squared, right, because A times A is A squared, minus the square root of AB, plus the square root of AB, minus the square root of B squared. Well, that's interesting. These cancel out. 1's plus, 1's minus. Square root of A squared is A, minus the square root of B squared, which is B. Cool. In fact, that's important. Okay, so multiplying when you have binomials, okay, distributive property, FOIL, split distribute. Radicals with radicals, numbers with numbers, square roots with square roots, cube roots with cube roots, okay? You're multiplying the numbers underneath the radical, or the variables, whatever's underneath the radicals get multiplied together. What's in front of the radicals gets multiplied together. Simplify when you can. Combine like radicals when you can. All right, let's try this one. I know there's a lot happening here, guys, but it kind of all goes together with the multiple radical concept. When you rationalize denominators and numerators, okay, you're going to be multiplying by the conjugate. Okay. That's spelled wrong. Conjugate's like a 10-cent word there. And what do we mean by conjugate? Is that it is the same binomial with opposite sign between the two terms. That's the best way I can describe it. Okay, so this guy up here, they're conjugates because the square root of A plus the square root of B. The other one's the square root of A minus the square root of B. The two binomials are exactly the same, except the middle sign is different. They're opposite. One's plus, one's minus. Now, why do we care about that? Look what happened when we did it. Okay, the middle terms, the two that we normally add together, canceled each other out. So there's no more middle term. Okay, so that's really, really important. that we can't end up canceling out the middle term. And also look what happened is that when we multiplied our radicals, they became perfect squares and we could square root them. No more radicals in the denominator of the fraction is why we do that. So that's why we're going to multiply by the conjugate. There's no more radicals in the bottom of the fraction. We're all good. Now, if we need to move the numerator, we're going to do exactly the same thing. Okay, so let's try this. All right, so we're going to look at our denominator and we see 7 plus the square root of 3. We're going to multiply by the conjugate, which means I'm going to multiply the numerator and denominator by exactly the same thing. So I'm going to go 7, the sign is plus, so I'm going to make it minus square root of 3. Same with the numerator, 7 minus the square root of 3. If it helps, put parentheses around all of this. So we're noticing the top, we're going to have to distribute. So 28 minus 4 square roots of 3. Again, 4 is not underneath the radical. We cannot multiply it by the 3. In the denominator, 7 times 7, 49. 7 minus square root of 3 plus 7 square root of 3 minus the square root of 9. So all I do is FOIL. Okay, so we can't do anything. 28 minus 4 square roots of 3. Can't add them. They don't have the same radicals. Okay, these guys in the middle are going to cancel each other out. They better be exactly the same. If they're not, you're wrong. Okay, and this becomes 49 minus 3. Let's take it to the next level. 28 minus 4 square roots of 3 all over 46. Are we good? Okay, awesome. Now, if you want to, do we all see that 28, 4, and 46 can all be divided by 2? We can divide everybody by 2. So we can divide this guy by 2, divided this guy by 2, divided by this guy by 2. And so we can make this 14 minus 2 square roots of 3 all over 23. Okay, notice I didn't touch the 3 because he's underneath the radical. You can't touch him. Okay, let's try another one. Okay. All right, so we have 5 minus the square root of 2. Okay, so on the top and bottom, 5 plus the square root of 2, 5 plus the square root of 2. Look at that. We're going to have to FOIL the tops and the bottoms. Okay, so let's just do this straight across. We're going to get 20 plus 4 square roots of 2 plus 5 square roots of 2 plus the square root of 4. Okay, so we're going to get, forgot my square root. Square root of 25 plus the square root of 10 minus the square root of 10 minus the square root of 4. Don't cancel out the 4s, okay? 1's a plus 1. You can't do that until everything's multiplication. All right, so let's see what we can get here. Well, first of all, we can get rid of these guys because they're exactly the same. Okay, in the numerator, we're going to get 20 plus 9 square roots of 2. Square root of 4 is 2. Denominator, 5 minus 2. All right, let's put some things together here. We get 22 plus 9 square roots of 2 all over 3. Okay, so unlike the previous problem where I was able to take a 2 out of all of them, okay, here I could take a 3 out of the 9 in the denominator. We can't do that. It's all or nothing, okay? All right. We're almost done, guys. We're almost done. Okay, so numerator, we're going to do exactly the same thing. Let's just do one of these. 4 minus the square root of 2. 4 minus the square root of 2. Okay. So we're going to get 16. It's going to get ugly. 16 minus 4 square roots of 2 plus 4 square roots of 2 minus the square root of 4. Okay, so what happened in the denominator in the previous problem is going to happen in the numerator of this one. So here we get 4 square roots of 5 minus the square root of 10 minus 4 square roots of 2 minus plus the square root of 4. Okay, let's clean it all up. 16. These are going to cancel each other out. Okay, minus 2. 4 square roots of 5. Fortunately, the 10 in this, we can't add, nothing gets added. And the square root of 4 is 2. So, 14, 4 square roots of 5, that was a bad square root, minus square root of 10, minus 4 square roots of 2, plus 2. Okay, we're only going to do one of those. Okay? All right, because my video is running long and I don't want to go too much longer. All right, so when we have different indices, all we're going to do is convert to rational exponents. Okay, so convert to rational exponents. And then we're going to do what we can, okay? But the big thing is to convert to rational exponents. All right, so for example, I'm going to take this x plus y, fourth root, and make him x plus y to the 3/4 over x plus y to the 1/2. Now, they're exactly the same. We're going to be able to subtract our exponents, but 1/3 minus 1/2. So I got to make this x plus y 3/4 minus 2/4. So we're going to get x plus y to the 1/4, and then we're going to convert it back to the 4th root of x plus y. So we did this before, okay? Just convert it to rational, do the properties of exponents, and then convert it back, okay? Same thing here. All right, so we got 3x to the 1/2, and then 3x to the 2/5. Ugh, that's going to be 10, right? Yeah, that's going to be 10. So this becomes 3x. So we got 5 over 10 minus 4 over 10. So that's 1 over 10. So, whoop, forgot my parentheses. So 3x to the 1 over 10, which is the 10th root of 3x. Okay? All right. So those kind of are like right here, and there's a variety of problems here. Let's just do 4 and 6, and then we'll call it. So this is x to the 1/2 times x to the 4/3. So we need a common denominator of 6. So x to the 3 over 6 times x to the 8 over 6, which is x to the 11 over 6, or the 6th root of x to the 11th. Okay? Now we can simplify that to x and then the 6th root of x to the 5th. Okay? All right, let's do this one. All right, so we got x to the 15th, y to the 7th, over to the 1/5 power. Okay, and then x squared y to the 1/2. Now, since they're not exactly the same, we can't just like subtract the exponents. So I'm going to give everybody the 1/5. So x to the 15th to the 1/5 power is x cubed, y to the 7/5, x squared, y to the 1/2. Okay, subtract your exponents, so we get x. All right, we've still got to do 10, so this is 14 over 10. This is 5 over 10. So that's going to give me y to the 9 over 10. I think, yes. Okay, so you're going to get x 10th root of y to the 9th. All right, sorry I went a little long-winded today, guys. Please let me know if you have any questions, and I'll talk to you again real soon.